let's continue with this video 3D geometry. Okay, so the first thing, the importance of this 3D geometry in the examination point of view, dear students, we have 11 marks. So there will be total 11 marks to the final exam from this chapter, in which there will be one marks question, one 2 marks question, one 3 marks question, and one 5 marks question. So totally there will be total 11 marks. So which is almost, I feel, easiest, simplest, and one of the important chapter of second year. Okay. So dear students, in the previous year we have studied analytical geometry in 2D and in 3D. In Cartesian form, we have studied analytical geometry 2D, in 3D, and in Cartesian form. Well, this year we are going to study the same 3D. This year we are going to study the same 3D in vector form. I mean, in the previous chapter we have discussed the vector algebra, correct? So that vector algebra concept I am going to apply in the 3D geometry. I mean, I am going to take the help of vector algebra to study the 3D geometry. So let us check it out. What are the things we are going to study in this 3D geometry? So in this, the first thing as usual, we are going to study the basic concepts which you are studying in the vector algebra. The same basic concepts will come here, okay, or in the 11th standard what you have studied. And next thing we are going to study the direction ratios and direction cosines, which already you know clearly, which you are discussing in the previous chapter, and equation of a line. Yes, dear students, we have discussed the equation of a line the last year in Cartesian form. So this year we are going to study it other than Cartesian form, I mean in the vector form. So what difference is there, the equation of line in Cartesian form and in the vector form? I will let you know that things later. Okay. Next we are going to study the equation of a plane. And next, distance between two lines, shortest distance between two lines. Along with that we are going to study the angle between two lines. So what is the angle between two lines? And angle between two planes. Imagine these two are planes, angle between two planes. And again we are going to study there angle between a line and a plane. A line and a plane. And next, the last thing we are going to study the distance of a point to the plane. Distance of a point to the particular plane. So these things we are going to study in this 3D geometry. So these are the things which you need to make perfect from this 3D geometry. Okay. So I'll let you know which are the questions are for 1 marks, which are 2 marks, which are 3 marks, and which are 5 marks. There is a compulsory, definitely, one theorem from this chapter every year from the 3D geometry. Okay, now first let me make you clear what difference is there between the Cartesian form and the vector form. I mean, if you present the point in the Cartesian form and in the vector form, how we will get differentiate. Okay. So now let's see, dear students, in the last year we have discussed the point x, y, z. Let me take one point x, y, z. Okay, so this point I can represent this way, or 1, 2, 3, or 3, 4, 5, whatever it is in particular space. If I represent this way, this we call it as a Cartesian form. If you represent in this way, this we call it as a Cartesian form. Okay, the next one, suppose the same point if you want to represent in the vector form. So the same point in the vector form will be xi plus yj plus zk. X, y, z, when it is in the Cartesian form, if I take it into the vector form, it comes like xi plus yj plus zk. Okay, now let's move to the equation of a line which you are studying in the last year. When in the 2D. Okay, I am taking on 2D. You can go to even 3D also. So let me take the 2 points. Yes, already we know. Definitely there will be only one line can pass through the 2 points. Okay. So now I have taken this line passing through the x1, y1 and x2, y2. So the Cartesian form, I mean the equation of this line in Cartesian form is, as already we know, y minus y1 is equal to x minus x1 into y2 minus y1 divided by x2 minus x1. Correct? Suppose I want to represent this equation of the same line in Cartesian form. So first I need to find this line. So that will be x2 minus x1 I plus y2 minus y1 j. Sorry, I have taken it in the 2D. So this one no need. Okay. So this I have taken it is in 2D. If you take it is in the 3D, you need to mention that one. Okay. Now let's move to the next concept. What are things we are going to study? Okay. I hope it's clear. So this is the equation of a line in Cartesian form and the equation of the same line in vector form. This is vector form, this is Cartesian form. Yeah, now let's move to the direction cosines and direction ratios of a line. So now let me take a line in a space. I'm going to take one line in space. Okay, let the point be P of x comma y comma z, whatever the point. Okay, so now that line makes an angle alpha with x-axis, beta with y-axis, gamma with z-axis. Okay, so then what will be the direction cosines of this vector OP? So this is vector OP. Now what are the direction cosines of this vector OP? So I will be getting here cos alpha, cos beta and cos gamma. Now my question is there any other direction cosines for the same line? Yes, let me check out. So now I'm going to do here, taking the opposite direction of the vector OP. I mean, I'm going to reverse the vector OP. So this is my vector OP. I'm going to take in the reverse order. So when I take in the reverse order, that angles alpha, beta, gamma, what I have taken, that angles will be replaced with pi minus alpha, pi minus beta, pi minus gamma. Will you agree with me? Yes. Compulsory. See? So I have taken a line in space. When I have taken a line in space, that makes an angle alpha, beta, gamma with positive direction x, y and z axis respectively. Okay. So now just I am going to, that means you came to know what are the direction cosines of that line vector OP when it goes in one direction. Suppose if it goes in another direction, it means it's going in the opposite direction. If I reverse it, so then I will be getting the angles pi minus alpha, pi minus beta and pi minus gamma. Then what will be my direction cosines? Now my direction cosines will be cos of pi minus alpha, cos of pi minus alpha, cos of pi minus beta and cos of pi minus gamma. So with your permission, I am going to write it. Cos of pi minus alpha is nothing but minus of cos alpha. I hope I can. Correct? So cos of pi minus beta, I can write it as a minus cos beta and cos of pi minus gamma is equal to minus cos gamma. So that means, so when you reverse a vector, particular given vector, when you reverse it in direction, when it goes opposite direction, you will be getting the same angle, cos alpha, cos beta, cos gamma, but in the opposite sign, means negative sign. So with this I am trying to say here, a particular line, see this is a line, a particular line will be with the two set of direction cosines. A particular line will be with the two set of direction cosines. To see here, there will be always two set of direction cosines to a particular line. So if you want to get a particular direction cosines, because so if it goes one direction, there will be one direction cosines, and if it goes reverse, there will be another direction cosines. Means for every line there will be two set of direction cosines. But so that's the reason always we need to mention the particular line with the direction. So compulsory you need to mention with the direction, any line. Then only you will be getting the particular direction cosines. Okay. So now let's move to the, as I have said you, we are going to study the direction cosines and direction ratios. So now again I am going to take a vector OP or point P in space x, y, z. Okay. Then the OP, vector OP will be, so this is my vector OP, that I am going to take it as a vector R as xi plus, I mean the position vector of that P is xi plus yz plus zk. Correct? So here the direction ratios which you have studied already. Here x, y and z are called the direction ratios. Correct? Here x, y and z are called the direction ratios of vector OP. Then here cos alpha, cos beta and cos gamma. See, these are the angles making with, this is alpha and this is beta. So this is the angles made by that vector OP with x, y and z axis. So we call it as a direction cosines. I mean cos alpha, cos beta and cos gamma are called the direction cosines. Now we are going to study what is the relations between the direction cosines and the direction ratios. This is the direction ratios, this is the direction cosines. So what relation is there between the direction ratios and direction cosines? That we are going to study now. I hope it's clear now. Direction ratios and direction cosines of a given vector. Correct? So as I said now, we will study now relations between the direction cosines and the direction ratios, which are already studied also in the vector algebra. Anyway, let me write once again. So vector OP, I am going to take the vector OP is a xi plus yz plus zk. Let me take it as a vector shortly. Okay. So now already you have represented cos alpha, cos beta and cos gamma by L, M and N. Correct? I am taking cos alpha as a L, cos beta as a M and cos gamma as a N. So and the very important property, how it come also we have discussed in the previous class and the previous chapter, that is L square plus M square plus N square is equal to 1. L square plus M square plus N square is equal to 1, and the magnitude of R, I mean the magnitude of this vector OP is equal to root of x square plus y square plus z square, correct? These are the things which we have discussed in the previous chapter. And that means then what's the relationship between this direction ratios and to the direction cosines? That is x is equal to, so x is equal to r into, r in the sense I am taking it as the magnitude of the given vector. Okay, so x is equal to r into cos alpha, y is equal to r into cos beta, and z is equal to r into cos gamma. If you have doubt how it comes, already we have discussed the previous chapter, please go through once again. Okay, so there you will get a clear idea how we get x, y and z as a r cos alpha, r cos beta and r cos gamma. Even how we get this also in this one also. We have discussed these all the things. Okay, so now just I am trying to relate between the direction cosine to the direction ratios. I am trying to relate between the direction cosines to the direction ratios. Okay, so that means x is equal to r into cos alpha. I think I can write it as a cos alpha is equal to x by r. This r goes this side, means x by r, correct? Cos alpha is equal to x by r. Similarly, cos beta is equal to y by r. So y by r. R is nothing but magnitude of r, means root of x square plus y square plus z square. Okay, so cos gamma is equal to, cos gamma is nothing but this is a representation Lmn. Okay, that's nothing but z by r is nothing but z divided by root of x square plus y square plus z square. So now this is a relationship between the direction cosines and ratios when they are given the vector OP. I mean one origin and one point, the direction line of that OP. Okay, so now we are going to discuss what is the direction cosines and direction ratios when they are given the 2 points. When they are given the 2 points. So now let's discuss the direction cosines of a line when it is passing through the 2 points. Now just imagine P of x1, y1, z1 and Q be the point of x2, y2, z2 be the in space. P and Q are there are 2 points are in space. Okay. So first I need to find here vector PQ, correct? I need to find the first vector PQ. So already we know how to find a vector PQ. Position vector of terminal point minus position vector of initial point. So that is I will be getting here x2 minus x1 plus y2 minus y1 plus z2 minus z1. This respective I, j, k. So this is my vector PQ. So now what is the direction? So now these are x2 minus x1 plus y2 minus y1 j plus z2 minus z1 k. See, already we have studied what are the direction ratios. See, this is the vector r. This is the vector r or OP xy plus yj plus zk. Here coefficient of I, j and k are called the direction ratios of that particular given vector. Correct? Will you agree with me? Yes. X, y and z are the direction ratios of the given vector. So then when it is passing through, when the given vector is passing through 2 points, then what are the direction ratios here? Yes, first I need to find out that vector PQ particularly. Then I will be getting here direction ratios. I mean here direction ratios of the vector PQ. The direction ratios of vector PQ are x2 minus x1, y2 minus y1 and z2 minus z1. This is my direction ratios of vector PQ. Yes, I got here vector PQ direction ratios. Then I need to find the direction cosines. Again, just compare with the previous. So what are the direction cosines there? Cos alpha is equal to x, means coefficient of I divided by magnitude of that vector. Correct? So here also, so now I need the cos alpha of what? Vector PQ. So here cos alpha is equal to, again the coefficient of I, that is x2 minus x1 divided by magnitude of PQ. So what is magnitude of PQ? Magnitude of PQ is here root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. So now I need to find the cos alpha, cos beta and cos gamma. Just do this x2 minus x1 by vector PQ, magnitude of vector PQ, and cos beta is equal to y2 minus y1 divided by magnitude of PQ, and cos gamma is equal to z2 minus z1 divided by magnitude of PQ. So this is the way I can find out the direction cosines of the given vector when it is passing through the 2 points. So dear students, in the previous chapter itself we have discussed what is the direction cosines of a given vector when it is passing through the, I mean with respect to the origin, we have discussed. So what is direction cosines, what is direction ratios, and the relationship between the direction cosines and the direction ratios. So now in this we have studied or we have discussed the direction cosines and direction ratios of a given vector when it is passing through the two given points. So let us complete. I hope it is clear the points whatever I am discussing. Now let's move to the problems related to this concept.